I started the validator project, and what I wanted out of this particular validator implementation was that the backend database would be just the file system, because that meant that I could use Unix utilities like find and grep and awk and whatnot to easily interact with the RPKI data. And once we had a backend that mimicked or that was the file system, not much later, I thought to myself, hey, what if I just tar and gzip this directory that contains all the validated RPKI information and store that on a server for people to download as like a snapshot in time of what the RPKI looked like at a particular moment in time.
You're listening to Ping, a podcast by APNIC discussing all things related to measuring the internet. I'm your host, George Michelson. This time, I'm talking to Job Snijders from the Netherlands about his archive of past states of the worldwide RPKI repository system. RPKI is a public key infrastructure about routing. It uses X509 certificate extensions defined in the IETF process to encode a signature over the Internet number resources held by the certificate owner. Internet number resources mean the IPv4, IPv6 and AS numbers that have been delegated. These certificates are used in turn to make more certificates and to sign routing security objects like the ROA or Route Origin Attestation. All these cryptographic objects are visible on the Internet in different places called repositories. They're fetched by an HTTP protocol or by the rsync file system synchronization method. BGP speakers worldwide are expected to fetch all these certificates and signed objects frequently, validate them, and recompute the certified statements about BGP routing. This process is Route Origin Validation, or ROV, and it helps secure BGP. Job has been collecting this information for some time now and holds an archive of the different states of validation over this data and the dynamics of changes inside the system as a whole. Job, welcome to Ping.
Hey, George. Thanks for having me.
Can you tell the audience a little bit about yourself in a couple of sentences?
Sure. My name is Job Snijders. I'm based in the Netherlands, and I am a big fan of the RPKI. In my day-to-day, I analyze the RPKI globally distributed database, I write RPKI software, and I work on RPKI standards to make things more secure and reliable. I'm a big RPKI fanboy, and I love to talk to you about RPKI.
Great. So people may know you because you've been really heavily involved in getting a validator, a client that looks at RPKI signed products and produces an output that people can use to perform BGP route validation. That's a suite of software written in C, is that right?
Yep. The software is called RPKI Client, and it is distributed as part of OpenBSD. And you use it to cryptographic validation of the RPKI data that RERs and resource holders publish on the internet. And I started this project in 2019 or so, because back then there wasn't a lot of choice for operators in terms of what validator software to use. And at the time, I worked for a global IP transit carrier, and it felt really important to make sure that there are quality choices for operators in order to allow them to embrace RPKI. Because if you tell people, hey, can you please enable prefix origin validation in your network? And they counter your question with, okay, but how do I accomplish this? And you can only recommend them poor quality software choices, then
or a narrow suite of software. I mean, the diversity that was available at the time wasn't very rich, really, was it? So this is a community that are used to seeing code developed in C, integrated into the platforms they're using for their route introspection analysis, internet routing registry. You added to the code diversity. It was a nice outcome.
Yeah, it's been quite a journey. I have to admit that when I started the project, I was not really a proficient programmer at all. And also my knowledge of RPKI at the time was far more limited than I thought it was. But, as a project like this cobbles along and you implement more and more aspects of the RPKI and talk to more and more experts, like yourself included, a deeper understanding of the RPKI materializes. And that's really a joy to work on.
So ping, it's all about measurement. And it turns out that you actually have also been doing a quite long baseline activity that isn't about software development of a validator. You've actually been looking at presenting some long-term stats about the RPKI itself. That's right?
I started the validator project, and what I wanted out of this particular validator implementation was that the backend database would be just the file system, because that meant that I could use Unix utilities like find and grep and awk and whatnot to easily interact with the RPKI data. And once we had a backend that mimicked or that was the file system, not much later I thought to myself, hey, what if I just tar and gzip this directory that contains all the validated RPKI information and store that on a server for people to download as like a snapshot in time of what the RPKI looked like at a particular moment in time.
So this is a really interesting approach to doing things. I mean, first of all, it's kind of honoring the ethos of Unix, simple tools, file system-based models, not reinventing the wheel, but using things that you have to hand that can say how big things are, how old they are. I'm interested how much it compressed. When you made a decision to hold tarballs and gzip them up, did you actually get an effective compression in this? Because these are cryptographic objects, and it's not uncommon for things that have gone through a cryptographic process to have a lot of the redundancy removed from them. Do these things compress well?
Oh, yeah. They compress with, I would say, 60-ish%.
Oh, wow.
So that's not too bad. And in creating these tarballs, I sort of mimicked the feeling that Route Views always gave me. With the Route Views project, you could go to one of their collectors and then download a RIP dump at that point in time. And they also archive like the BGP updates as they come in. But I wanted something that for the RPKI that was like Route Views. And so I called it very imaginative RPKI Views.
Well, they don't have a patent on the word views. This seems reasonable. Right, but I think also Route Views, that's a really nice comparator because this is an incredibly long-lived archiving activity. I mean, it's now going back into the 1980s. So you kind of have an exemplar there of the public good outcome. Let's just collect the state of the world as we see it. Was that in your heart? You were kind of thinking along those lines?
Yeah. I wanted something that like 10 years from now, we could still download these snapshots and analyze them as if they were generated today. So each archive nowadays is around 420 megabytes, give or take. And
compressed?
Compressed.
Wow. When you started, how big was that? It couldn't have been anything like that size.
Yeah, so I started in 2020 in December. Back then, they were 116 megabytes. So in like a few years, we've quadrupled.
Right. And you're taking this snapshot at what frequency? What's your cycle time?
There's multiple machines around the world. So there's one in Amsterdam, one in Zurich, one in Tokyo, one in the United States, and they are each on a slightly different schedule. So somewhere on the planet, a machine is making a snapshot like twice an hour. So if I pull together all the archives, I probably have a snapshot every 10 minutes or so of the RPKI.
Now, for people who don't know about the production cycle side, I'm in the fortunate position of having worked on some of that design in the very early days of RPKI. And for whatever reason, and we may have made the wrong decision, we kind of initially modeled the world in this validation framework as being not that frequent in updates. So BGP, transactional events, you make a change in routing, it kind of flood fills the surface of BGP in maybe 30 seconds to a minute. RPKI, it just behaves a little differently, doesn't it?
Yeah, it is very different. It's very interesting to compare the dynamics of the two. But for instance, so most ISPs deploy 2 or 3 validator instances, sometimes from the same brand, sometimes from different vendors.
So they're getting both diversity in terms of the software platform, but also they've got 2 independent points to look at the stable state of RPKI as they see it.
Right. And then you have all your BGP routers that have a connection to all your validators. So that's like a mesh. And the funny thing is that the moment one of your validators sees a new ROA, it like immediately propagates to all your BGP routers. But for a revocation or a deletion of a ROA, all your validators need to have seen that. So new information in RPKI percolates quite fast through the ecosystem.
New additive information, but subtractive information, I guess that would be because the validator that still holds the valid object asserts this is a cryptographic object that still has life. And until both of them say, nope, it's gone, somebody's asserting its value.
Right. So imagine you have validators that are running on a 20-minute interval. So the top of the hour, 10 past the hour, 20 past the hour, the validators kick off their process, and half an hour later they start it again. That means that the creation of a new ROA could propagate no slower than within 10 minutes, whereas the deletion would,
on average,
take up to half an hour.
Yeah.
I think for all practical purposes, this is an interesting quirk, but operationally, it's not super relevant.
But nonetheless, what we're starting to see is from the practice that most operators have of running multiple validators independently, they are probably going to observe this interesting dynamic. New states can be fast to acquire, but withdrawals of state can be slow to come out of your system. And it is nothing like the speed of BGP. It's not the speed of an announce or a withdraw event. So how do you feel about people who are only downloading once a day?
Downloading once a day is not often enough in the cycle. The cadence at which signers produce data and publish ahead. So imagine a signer signs over a new version of the CRL and manifest, and it says, this is valid for the next 8 hours. And it might make such a statement every hour. So this means that every time you synchronize, you'll get information that is still good for another 7 to 8 hours-ish. And this 8-hour cadence, you see that a lot in the ecosystem. So if you synchronize every 24 hours, a lot of the information briefly blips out of existence, and that's unhelpful.
For people who are used to traditional PKI, the manifest is a structure that doesn't actually exist in a lot of people's methodology. They're used to the idea of CRL, the revocation list, but the idea of a catalogue of things that must be seen. And the implication, if you find objects that are not on the catalogue, they might actually be objects that should not be considered. That actually is subtly different to most PKIs, isn't it?
Yeah, that's a weird quirk. And there's another interesting aspect. Every validator synchronizes with every publication point. So with BGP, the information just comes to you. With DNS, you only ask for what's relevant for the question at hand. But with RPKI, the validator constantly slurps in everything it can get its hands on because it might be relevant, or maybe not.
There's this aspect that to validate states of global routing, there really is a strong implication. You have tried to fetch all global states of signed assertion. You have to get the lot.
In having to fetch the global state from multiple locations. So in my RPKI review, I say something like, hey, there's 53 publication server, fully qualified domain names. This means that every validator needs to connect to 53 places and fetch in data. Now you can imagine that on the internet there's transient issues, and maybe temporarily one validator cannot reach one particular repository because there's a brief routing issue between the two endpoints. So if you synchronize only once a day, you make an attempt to connect to that remote point. But if you synchronize every 10 minutes, that means you're making more than 100 attempts a day to reach that publication point. So not only is there an argument like, hey, we want information to propagate in a expedient manner through the ecosystem, but we also want to put in honest effort to try and synchronize with repositories where the connection is lossy or high latency or has issues.
We could go down a hole of discussing should you be hosting critical security information on an unreliable, lossy connection, but that kind of goes in a different direction. The quality here, though, is...
Well, maybe it's not the publication point that is on the lossy side, right? It could be the validator. So whoever is causing the loss in the middle between the two endpoints, if the validator makes more than 100 attempts a day, it at least is increasing its chances of retrieving a current state of the repository.
Give us a heads up. What's the state of the planet for RPKI right now?
Before I delve into the metrics I collected, let's go back to an earlier fork in the conversation. I mentioned that I created a validator that uses the file system as a backend.
Yep.
And then I was like, oh, I can just put that directory in a tarball and publish this, and who knows what kind of use it has. And then at the end of 2020, so as 2021 was looming around the corner and, a lot of the world was bunkered in the lockdowns and because of the COVID virus, I was a bit bored. And I looked at my archives and I was like, oh shit, I have more than a year worth of tarballs and I can just maybe compare the two.
Yeah.
So I wrote this report comparing what I had collected in the 13 months prior to that. And I thought it'd just be amusing for my fellow RPKI colleagues to sort of have a focal point of potential discussion, like where are things heading? Is it good? Is it bad? Like what is cost associated with some of this in terms of bandwidth transfer or processing or whatnot?
You were seeing it as part of a conversation between you and people in the operational space and in the standards development space. What's pace of change? What's going on in the world? How are the burdens of people that are using this technology going to alter? But also, what's going on inside? I mean, you're collecting a tarball, but you're not just saying the tarball got 4 times bigger.
Right.
There are so many questions that are potentially answerable from inside this information space. So which ones are you looking at?
An obvious one is the uncompressed size. So last year, the snapshot uncompressed was almost 1.5 gigabytes. This year, it's 2 gigabytes. So that's like a 31% increase. And every validator needs to store the valid objects or the objects that at that point in time were valid somewhere in either RAM or an on-disk database or on-disk file system. And validator implementers can maybe optimize a little bit doing compression in their backend or not. But ultimately, the uncompressed state must be stored in some form in a lossless format in order for validators to produce validated payloads. So this is a really good indicator that we need to consider when planning new features for the RPKI. I don't know. So if you were to be like, hey, Job, I want to publish the audio recordings of this podcast in the RPKI database, I'd be like, George, that is really cool that we could,
not a good idea.
Fetch that information. But we're already at 2 gigabytes and your recordings are like 100 megabytes each. So I don't think we, can sustain growth at this pace on all the validator instances.
So we're looking at a routing community that in terms of discrete BGP speakers who have an AS, an autonomous system number, rule of thumb, it's 80 to 100,000 people who are asserting origin over some routes. And those are the people who ultimately need to have ROAs made either by themselves or by the delegate of the address if they don't hold the address to say, these are the valid routes I want to originate. And that's before we discuss the newer object type, the ASPA object, which is a slightly different assertion between BGP speakers about their associations. How many of the BGP speakers are producing or having produced on their behalf ROA objects, rough numbers?
Well, with ROAS, it's of course the prefix holder, not the AS holder who produces the ROA.
Right.
But the prefix holders in their ROAS are referencing now 47,000 unique autonomous system numbers. That's up 16% from last year. If you look at the global routing table, there is roughly 81,000 ASNs visible in the default free zone. I think at the moment there's almost 100,000 ASNs assigned, but not all of them are visible. For all intents and purposes, more than half of the ASNs that are in use are referenced in some ROAS somewhere. So That is a really cool.
That is a phenomenal outcome when you compare to IPv6 that is 20 years plus in its lifetime and only just approaching 50% uptake in some areas. I mean, India's at 90. Asia Pacific footprint's going to break 50% in the next month.
Yeah.
Worldwide, we measure it more like 30 to 40%. Well, in half or less than half the time, actually significantly less than half the time, RPKI is deployed to cover 40 to 50% of the BGP space. That's amazing.
But it's also an unfair comparison, right? Because the moment, like deploying IPv6 is like much like deploying a new network, and it's a significant effort. But once you've deployed IPv6 alongside IPv4, then doing RPKI for both v4 and v6 is basically the same project, the same effort.
The burden to deploy here is actually quite low. You go as an administrator into some system, either self-hosted or in your registry, and you press buttons and you have made it happen for you.
Right.
But you then acquire a maintenance burden as you change your routing surface. You have to come and recommit in this framework. So there is an ongoing engagement.
In a similar way, supporting Quad A records in your DNS infrastructure alongside of supporting A records is a minimal burden, right? Because your DNS server is likely to support Quad A records on the authoritative or resolving side out of the box. So it sort of comes for free with the fact that you deploy DNS at all. And yeah, I do like the comparisons, like RPKI is growing faster than IPv6, but they are to a degree nonsensical.
It's only to introduce the competitive spirit. So if it's at 40% uptake by the AS and the routing component there, how much of the address space is now covered by these signed objects?
In IPv4, 2.7 billion addresses are covered, and if you deduplicate that set, you are at 1.6 billion IPv4 addresses. Now, if you subtract things like documentation space and the E-class that is not usable and blah, 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 we're like 54% of routes in the global routing table are covered by ROAS.
Oh, wow. That's really quite respectable.
Yeah, it's more. But what's even cooler, Kentic, a US-based company that correlates IPv6 and NetFlow data to BGP information and also to RPKI information, they estimate that 74% of traffic that flows over the internet is headed towards destinations covered by RPKI ROAS. So almost like a little bit more than half of the routing table is covered by ROAS, but essentially 3/4 of traffic are going towards ROAS protected destinations.
That difference between the amount of BGP asserted routes that exist and the amount that actually carries useful traffic on behalf of end users, it is fascinating.
Yeah.
And I think that higher trend is really very interesting. So we mentioned the ASPA, which is a slightly newer cryptographic object. Have you started to track that as a discrete value in your measurement?
Yep. I am tracking the number of unique AS holders that have produced an ASPA object. And at this moment in time, if you want to produce ASPA objects, you need to jump through a number of hoops. None of the 5 regional internet registries supports creation of ASPA objects in the production environment. And I think this is a good thing because the ASPA standard is not finalized yet. So it's not yet ready for prime time.
Yeah.
And the moment an RER makes it available in the production environment.
It's baked in stone at that point. Changing the bit pattern gets hard. But that actually says to me that, first of all, you're seeing the early adopter tests. And secondly, you are effectively measuring ground zero.
Yep.
You're measuring ground truth before this takes off. So this idea of a long-lived collection, you have an opportunity here not to come into something midstream, but to actually say, what was the lifetime uptake? What was the logistics supply curve? That could be really lovely.
So between last year and this year, it went from 56 unique customer ASIDs, as they are called in the ESPA terminology, to 87. So that's a 55% increase, but we're still only in double digits.
Yeah.
So that is super early days for global ESPA deployment. It essentially means that, a number of RPKI developers and hobbyists managed to jump through the hoops to produce such an object. And it's great for testing. It's great for kickstarting that cycle between getting some operational experience with the technology and feeding that back into the IETF process. But it also means that ASPA filtering, it is not 0%, but it's really, really early days for this technology.
Now, if I have this right, you're not currently doing a comparison to this state and to actual BGP state at the time you fetch. So you're not doing analysis of valid and invalid routes, or are you doing that?
No, I'm not. In this report, I only look at the data that is contained within the tarbles and do comparisons between the data of tarbles throughout time.
If somebody else wanted to take these repositories and fetch route view snapshots of BGP at the same time and do a comparison and assert valid and invalid views of routing, they could do that, right?
Absolutely.
So the repository is like a tool in its own right. It's available for other people to use, as well as the report that you're publishing.
People do all kinds of interesting things with these tarbles that I had absolutely not foreseen. So a nice example is 2 years ago, people looked at in an RPKI signed object, so for instance, a ROA or a manifest, apparently there's a hidden timestamp when the thing was signed. And this timestamp was not immediately visible in common utilities that display information.
Right, because typically what people see is the file date when the synchronization between the repository and the local copy. That file date and that certificate date, that is not the same as the date that you say, I want this to be. They're different.
But because I was storing the real raw files, so not an interpreted version of the objects, but the actual binary bits that go into the validation process, these people were able to extract those timestamps and then make a whole study of how long it takes for RPKI data to propagate through the signer pipelines. I didn't even know that data was in the tarbles. And
I believe you've told me before that Massimo Candela in NTT is using the data as part of his BGP alerter service. Is that right?
For every run of producing an archive, I also try and produce a JSON interpretation of the snapshot at that point in time. And BGP Alerter has this feature where it will warn you that a ROA is about to expire, but it will also tell you which ROA that is, and correlating the payload that is consumed by BGP routers to as it exists in the system. Those lookups, my data helps his product to do those.
So thinking about your archive, you're incurring a burden here storing data. I mean, you say the uncompressed size is 1 to 2 gigs, but even at 400 meg compressed, this is a very large burden if you're collecting at multiple points on the surface. What's your daily disk burden here? What are you looking at?
So on a daily basis, one of my nodes, the one in Amsterdam, they are doing like 50 snapshots a day. And that's about, at this point in time, 20 gigabytes a day stored on disk.
Right, from one node. And you said you had 5 nodes, I think, 5 or 6.
Yeah, there's a bunch around the world. Not all of them run at the same cadence because the CPU, for instance, is not the same in every node. So they can't go as fast as every other node.
Yeah.
You know, you're looking at terabytes per year. On the upside, storage has gotten really cheap. And if, you know, this is not storage that requires a lot of IOPS or random seeking.
It's also not S3 cold storage. People are reading this data. So in principle, assuming you put this into cloud storage, you're covering both the write and read side. You don't have a backer on this one, do you? You're doing this by yourself.
Yes. Well, there's a few people that contribute resources and donate disks from time to time. So I do the management. There's a small group of people that are interested in contributing resources.
Folks, he's too shy and retiring to put the call out, but I'm going to do it on his behalf. If you like this service, you should get in touch with Job and you should help him with disks. Do you need CPU as well? Could you use a hand there with CPU compute?
So my perfect server would have like 32 gigabytes of RAM, 4 CPU cores, and then maybe 10 or 20 terabytes of disk storage, potentially more if that's available. So you can take a really cheap commodity server and just stick 10, 12 terabyte disks in them, and you're good. It's not about network bandwidth. It's not about CPU or RAM. It's just raw storage in a RAID 1 or RAID 2Z ZFS construction.
Well, I really hope we can find some people to get involved. Now, it sounds like you're really focused on treating the archive as a fairly straightforward, simple thing, but there's potential for a GUI here, right? I mean, some level of interface into the information space.
Yeah, I haven't built a GUI myself because I'm not good at it, and I could benefit from somebody that is like, yeah, I want to create a GUI for a database that contains millions of objects. And so I think from my side, I do understand the relationships between the objects and the constraints that should exist in a database scheme. But having somebody that helps with visually exposing this in a searchable manner, that'd be a great collaboration. It's a lot of data, so there are some challenges here.
Yeah. Now, people may also not know that the repository structures are available through two protocols, and viewed objectively by an operator, it's kind of belt and braces. There are reasons that this is useful because it means there are two discrete different mechanisms you can use to sync. But from another point of view, this is kind of weird because you've also got potential for these to get out of synchronization. So I'm interested, do you actually fetch using both mechanisms, the rsync and the RRDP, the Delta protocol?
So the raw tarbals are produced following what is now the industry standard of you first try RDP, and if that doesn't work, then you try rsync. And in all scenarios, you also compare to the disk objects previously fetched available from the local disk.
Right. So is the file the outcome of a complete run of your RPKI client in terms of a single tree state of validated truth? Or are you holding the fetched objects, including the delta set and the snapshot set that are the primitives before you validate? I've never really understood if you have both.
The tarbals referenced from rpkiviews.org, they contain the validated state that is synthesized from either RDP or rsync.
Yep.
Inside the tarball is a file called rpki-client.metrics, which is in OpenMetrics format, which is used for Grafana Prometheus stuff. And in that file, it's annotated per repository whether RDP or rsync was used.
So you can actually decode the origin source, but you're not snapshotting the data that came in the origin. You're snapshotting the outcome of validation.
Right. So if you download a tarball, it contains all the raw objects that were valid at that point in time and cryptographically referenced from other objects leading all the way up to the trust anchor locator. And the reason I do this is it is possible in both rsync and RRDP to publish objects that are not hooked into the RPKI tree. So for instance, a PNIC could just put a PNG file on their rsync server or in their RRDP.
It would not be in a manifest file, and it would not be referred to by any cryptographic object that people are using to validate BGP.
So I'm not interested in archiving objects that are not linked to the cryptographic reality, because then the archive would just be needlessly large.
Well, there's the potential for a denial of service attack as well, like you said, with things like zip bombs that explode in size or insanely stupid large objects. But it also means, and I mean no criticism in saying this, it means there are questions you can't answer, like faulty encodings in the RRDP, because that doesn't primarily interest you. That's not part of what you're trying to measure.
Correct. But what I also archive is the log file of the validator instance. So if there is an XML encoding error, you'll see in the OpenMetrics file that it was unsuccessful in synchronizing on RDP. There will be a log line that says there was an error.
Right. You may not have the raw bits to look at, but you know the event happened during validation.
And it's not that I am super worried about the DOS factor in storing useless craft. It's just I've noticed that repository operators publish craft, and the burden of storing all that data is going to be so significant that I would need a lot more resources to store all that data.
Yeah.
Periodically, I reach out to RERs like, hey, are you aware that these years old certificates or ROAS are part of your publication. You don't need to.
Yeah, I've seen those mails, Job. I'm well aware that you've been reminding us to get on top of our game. You're in this for the long haul, aren't you? You're committed to doing this forward as long as you can.
Yeah. It's my hope we can do this for many years. And so another metric I have come to look at in the last 12 months out of necessity, it's a little bit of there's some embarrassment for me in this story. In writing an RPKI validator, you have to consider security aspects, and DOSs of some kind are a potential factor you need to consider.
Yeah.
Two things will come together in this brief story. A long time ago, I told an American ISP, like one of the largest, you should create ROAS for all your prefixes. And this American nationwide ISP was like, all right, Job, we will create ROAS for all our prefixes. As you say, sir, no problem. I'm like, cool. At the same time, I put in some limits in my validator. So I put in a limit that a single signed object cannot be larger than 4 megabytes, because I reasoned like nobody's going to create an object larger than 4 megabytes, because that would be indicative of really inefficient encoding, or, you're holding it wrong.
Yeah. I think we can all guess where this is going. This reminds me of the people who put an absolute limit on the number of prefixes they could ever have in BGP, because no one would ever have BGP of more than 65,000 prefixes, right?
So at some point, I'm looking at the data. I'm like, wait a second, this manifest file is 3.8 megabytes. What is going on? So I look at who is producing such a large manifest, and it's this American ISP that 2 years prior I told to create ROAS for all their prefixes, and throughout the last 24 months they've been steadily creating ROAS. And then it turned out that the RER Aaron, their system, if you use the web UI in like the default mode, it will produce a single ROA per prefix.
Well, there's a school of thought that is concerned about fate sharing. And so there was a point in time.
Let's get to that in a second.
Yeah.
So this ISP has potentially up to more than 55,000 BGP announcements.
Whoa.
So they create ROAS ahead of announcement rights. So they create ROAS for things they might announce in the future.
Yeah.
A manifest with a little bit over 55,000 entries is apparently almost 4 megabytes. So I called the ISP, was like, hey, there is a scaling concern in a lot of aspects that are unforeseen. So
I hope they didn't say, are you telling me you have a compiled limit in your C code?
Oh, absolutely. And I explained why the limit existed. And I also explained, like, the system has created about 50,000 individual ROA files, but if you aggregate them per origin AS, your data set is going to be 20, 30 ROA files, and then each ROA file has a few thousand prefix entries. So instead of using multiple, like 50,000 inodes and multiple megabytes on disk, you can compress all of this into 20 inodes and only a few hundreds kilobytes worth of data. So discussing this with the ISP, they were unaware that the system would create a ROA per prefix, and they were unaware that the Aaron system is also able to pack multiple prefixes into a single ROA. And Aaron, in turn, was unaware that multiple validators have multiple limits here and there that they were about to cross if not for automatic packing. So RPKI clients had this 4 megabytes per signed object limit. The fourth validator has a 1 gigabyte limit for the RDP snapshot. So if you encode a prefix per ROA, you essentially have like a 2000 byte overhead per prefix. And you can encode prefixes in just a few bytes. So
there's potential here for there to be a massive explosion in representation cost of what are really quite small objects.
And it's not just storage space, but verifying 20,000 certificates versus verifying less than 100 certificates is a massive...
Yep. Again, people may not know, they're used to PKIs where a single certificate is used to sign many, many, many edge objects, but validation comes back quickly in a tree to a single thing. In RPKI, we make end entity EE certificates on the fly, randomly, with keys we will never use again, and we sign one thing with them. So if you make one thing, that's one certificate. If you make 50,000 things, that's 50,000 EE certificates that have to be validated.
Every time you do a run of the validator.
Yeah.
So that's every 10 to 20 minutes. So as we went through the original, you're about to hit my 4 megabyte limit, and then I discovered there were way more limits in the ecosystem.
Yeah.
And the cost is disk space, inodes, CPU power, RAM.
This is something the community really needs to know and needs to understand. It's not something that should just exist as random values. We should have conscious knowledge of the operational limits. We need to work with it.
So I started tracking the number of ROA IP addresses per ROA.
Right.
The average. And in 2023, it was 2.7 prefixes per ROA. End of 2024, it was 2.3 prefixes per ROA, but that's not a good number, to be honest.
So if we bring fate sharing back to the table, you don't personally see a problem that if you have to perform a ROA withdrawal, all the associated prefixes become invalid in that ROA?
I think the fate sharing argument, especially in environments that are managed end-to-end by a single entity, so that's Aaron's hosted environment where you log into Aaron's portal or the My APNIC portal and you click to create a ROA or use the API. Those environments, the publication component, every component is managed by the RIR. So the RIR can harmonize or orchestrate its systems in such a way that creation or deletion of a ROA happens with the appropriate sequence of steps. So for those environments, you can do optimal packing of prefixes per ROA in such a way that you conserve disk space and CPU space and whatnot.
It's also this behavior that it's kind of perhaps a small amount of extra cost at the RIR making the packed state, but it is a massive per validator improvement in behavior. Less data on the wire, less compute time to validate, smaller data costs distributed in the global framework. It really is better for the commons.
And better for the RIR because the bandwidth cost of the RIR reduces as the RIR does packing. So if we compare two RIRs, and that was part of my 2024 report, under the RIPE NCC TAL, you get an average of 6.5 prefixes per ROA.
TAL is the trust anchor locator. So that's the pointer, the fundamental pointer that bootstraps finding a PKI trust anchor and all the descendant objects.
The starting point of the validation process. So everything you can validate on the RIPE, you yield like 6.5 prefixes per ROA file. So,
and under Aaron and APNIC, you said it was tending towards 2 and a bit.
I don't have the number for APNIC readily available, but for Aaron, that number is 1.1 prefix per ROA.
Oh, wow.
So there is an almost one-to-one mapping between prefixes entered in the various interfaces and then ROAs being minted by the signer machine.
Yeah.
So this is a really bad yield compared to RIPE's yields if we talk about efficiency.
Yeah.
So my hope is that next year, maybe this number has changed because I don't think if all RIRs were to change their systems to do one-to-one mappings between prefixes and ROA objects, the growth would be 6x or 7x maybe. And that's not growth I think we can sustain in the wider ecosystem.
We're kind of getting to a point where that's a conversation to be held in operations communities in the standards groups. But the truly interesting part for me in the podcast is that it's a product of measurement, right? This is kind of the utility side of doing these measurements and collecting data.
Right.
You got insights into dynamics of the system as a whole, and it helps you inform policy development and operational choices. It's exactly why people should do this stuff, Job. It's fantastic.
Yeah, this was a type of metric that I think nobody was monitoring, and it apparently was going up and to the right and in such a way that it stood out to me as like, there is potential problems down the road here unless we take some action.
Your report has been sent to a number of operational lists, mailing lists, standards group lists, but do you publish this on the web as well? Is there a URL people can go to?
It's adopted into a APNIC Labs article. So if you prefer HTML instead of plain text email, then just go to the APNIC Labs website.
And that has pointers to where people can actually fetch this data if they want to use this archive for themselves?
Yeah. And people should feel free to reach out to me that, like, if there's some aspect of the data you'd like to analyze, or if you're curious if some data is archived or not, I'm happy to share what I have. Oh, so going back earlier, you were asked like, hey, are you storing the validated outcomes or the raw RRDP inputs? Now, I also have some servers that are storing the raw RRDP inputs, like the actual snapshot and delta files.
Right.
But the retention time for those is only a few months because the amount of data that is flowing through RRDP is substantially larger than what you ultimately synthesize out of the validation process.
So if you compare this to route views, they're actually holding much smaller transactional changes with occasional dumps. RRDP, snapshots, and rsync state is the entirety of the state.
Yep.
It would be very costly to hold this long term. But it means that there is an opportunity to look back a couple of months if people want to see if they've missed something in recent time that's operationally relevant.
Yep. And usually when there's some kind of issue, like there's an encoding error, this problem will bubble up in a matter of hours. Like maybe somebody will text me like, hey, do you know why all the validators appear to be using rsync? And then I dig into this archive that has a few months worth of retention, but in reality, I'm just using the last couple of days worth of data. And I also have a machine that at the same point in time launches a validation one using only RRDP, which is not standards compliant because you have to use RRDP and rsync, only uses rsync and uses both RRDP and then rsync. And the validated outcome, so not the raw files, but like what is sent to the BGP routers.
You can then do comparisons and differences between these validation states.
Right. I do a three-way diff between the CSV files that come out of that to sort of understand, like, are you getting the same view depending on the transport? And that generally seems to work out quite well. Like people are fairly diligent in making sure that they publish the same data through RRDP as they do through rsync.
Job, that's been fascinating. That's really very interesting measurement activity. Thank you very much for coming on Ping and talking about it. Do you have some other work we could maybe talk about another time?
In my report, I also reflect RFCs that got published in the last 12 months. So I'd love to talk with you what publications the CyberOps Working Group accomplished and what that means for the ecosystem. But yeah, that's for another time.
I think that'd be fantastic. Yeah, that'd be really great. Thank you very much, Job. We'll make sure that people get a pointer to the article on the APNIC blog and to your website. Thank you.
And please, audience, if you want to dig into the archives and you have questions about how are they structured, what do the directory layouts mean, what do the files mean, how can I get like JSON formatted data out of these binary files, just drop me an email and I'd be happy to help you. So if you're a student and if you want to work on RPKI measurements, use my archive. It's the most detailed archive that exists on the planet, and it's just free and there for the taking.
Fantastic. Until next time, Job.
Thank you, George.
Next time on Ping, I'll be talking to Jeff Houston again, continuing the exploration of BGP routing. In an episode coming to Ping shortly, we're going to be catching up with people at the Apricot meeting held in Malaysia in February, and in particular, the Pulse Internet Measurement Forum, organised by ISOC at the conference. It's a slightly different format of podcast, with a series of short interviews, more voices in the measurement community heard in one episode. If you've got a story or research to share here on Ping, why not get in contact by email to ping@apnic.net or via the APNIC social media channels. Also, remember the Measurement at apnic.net mailing list on Orbit is there to discuss and share relevant collaborative opportunities, grants and funding opportunities, jobs and graduate placings, or to seek feedback from the community on your own measurement projects. Be sure to check out the APNIC website for all your resource and community needs. Until next time,